Hello students, in the last lecture we discussed about the properties of carbocations, carbanions and free radicals in detail. In today's session we are going to discuss about the easiest way to remember all the properties of carbocations, carbanions and free radicals at one glance, right? So let us start now the properties of carbocations, carbanions and free radicals. Okay. So see here. These are the properties of all these reaction intermediates. First property is a charge. Second property is a valence electrons. Third property is behavior. Fourth, hybridization. Fifth, bond angle. Sixth, shape of the molecule. Seventh, number of unpaired electrons. Eighth, magnetic behavior or magnetic nature or magnetic character. And ninth, that is the example. Okay, all these are the properties of carbocations, carbanions and free radicals. So let us discuss about the first property, that is a charge. Charge on the carbocation is a positive. See here, this is the carbocation, this is the carbanion ion and this is a free radical. What is the charge on carbocation here? Plus charge. So it is a positive, right? Charge on carbocation is positive. Charge on carbanion is negative. Here, charge on free radical is neutral. There is no positive charge, neither positive charge nor negative charge is there on the free radical species. That's why here the species is a neutral species. Okay, free radicals are neutral species. Now, second property, that is the valence electrons. Okay, valence electrons. Now count the valence electrons, total valence electrons. How many are the valence electrons here in the carbocation? Each bond has a 2 electrons. We know that each bond is made up of 2 electrons. How many bonds are here? 1, 2 and 3 bonds are here. So total electrons are 2 plus 2 plus 2, 6 electrons are there, right? Total valence electrons are 6 in number. Here in case of carbanion, count the total number of electrons here. 2 plus 2 plus 2, 6 electrons and plus 1 lone pair is there. How it will get lone pair? This 1 electron is of the carbon atom itself and another electron is of the another carbon atom, right? So it will get a negative charge. Okay, it has a 1 extra electron. Carbon's valency of carbon is 4. But it is having how many electrons around it? 5 electrons, right? This 1, 2, 3, 4 and 5 electrons. Means 1 electron is extra and that extra electron is attracted by the carbon from the another carbon. That's why it is getting the negative charge, right? So how many total electrons are there? 2 plus 2 plus 2 plus 1 lone pair, means total 8 electrons are there. Right, in the next species, that is the free radical, total number of electrons, that is 2 plus 2 plus 2. 3 sigma bonds are there, 1 bond, 2 electrons, right? Then 3 bonds equals to 6 electrons plus 1 free radical, means total 7 electrons are there, right? 7 electrons. Now coming to the third property, that is the behavior. Behavior, whether the given species is electron deficient or it is electron rich, how we can decide that? It can be decided by the number of electrons in the valency shell, right? Here the number of valence electrons are 6. Octet is not completed here. In case of carbocation, octet is not completed, so carbocation is a electron deficient species. It is a electron deficient species. Electron deficient species. And in case of carbanion, octet is completed. 8 electrons are there in the valency shell of the carbanion. Okay, so it is a electron rich. 8 electrons are there. Its octet is completed. Again, it has a negative charge, right? It has a negative charge. That's why it is a electron rich species. It is a electron rich species. Now coming to the next radical, that is a free radical, next species. Here 7 electrons are there, means it is also a electron deficient. Okay, its octet is not completed. Okay, it has only 7 electrons in the valency shell. Therefore, it is also a electron deficient species. It is also electron deficient species. So, carbocation is electron deficient species. Carbanion is electron rich species, and again free radical is a electron deficient species. Now coming to the fourth, that is the hybridization. Fourth property is a hybridization. Now by knowing the number of sigma bonds itself, we can find out the hybridization. Here 1, 2, 3 sigma bonds are there. 3 sigma bonds means the hybridization is sp2. 3 sigma bonds are there. 3 sigma bonds are there means hybridization is sp2. 2 plus 1, 3, right? So hybridization is sp2, and in this case 3 sigma bonds are there plus 1 lone pair is there. 3 sigma bonds plus 1 lone pair equals to 4. That it means that it has a sp3 hybridization. What? sp3. In chemical bonding, we have studied all details regarding the hybridization. We studied all things regarding the hybridization in the chemical bonding. Okay. Now let us try to understand how to find the hybridization by knowing just to the molecule by counting the number of sigma bonds and by counting the number of lone pairs, etc. Because only sigma bonds and lone pairs can participate into the hybridization. Pi bonds are not involved in the hybridization. Free radicals also not involving in the hybridization. Some exceptions are there, no doubt. We discuss all these things in the chemical bonding. Okay, so here hybridization is sp3, and here hybridization only 3 sigma bonds are there. Free radical is also there, but free radicals are not involved in the hybridization, right? So its hybridization is sp2 hybridization. If we know the hybridization, we can find the bond angle very easily. Right, for sp hybridization, bond angle is 180 degree, right? For sp2 hybridization, trigonal planar shape will be there. That's why the bond angle is 120, 120, 120 degree, etc. And in case of sp3, bond angle is actually 109 degree 28 minute bond angle will be there for the sp3 hybridization, which is having shape and geometry are same. If shape and geometry are same, then it has a tetrahedral geometry and tetrahedral shape also, right? If there is no lone pair in the molecule, then the geometry and shapes of the molecules are same. But if lone pairs are there in the molecule, then the geometry and shapes become different. Geometry will be different from the shape. Both are not same if lone pairs are present in the molecule. So here lone pair is present in this molecule. No doubt hybridization is what? sp3. But one lone pair is there, and that's why there is a repulsion between the lone pair and bond pair. That's why the bond angle decreases from the 109 to the 107 degree. Bond angle decreases. What is the reason? Because of the repulsion between the lone pair and bond pair. Lone pair bond pair repulsion will take place, and that's why the bond angle will decreases, and it will come to the 107 degree from the 109 degree 28 minute, etc. Right? So here this is about the bond angle of the carbanion. Now in case of the free radicals, bond angle is 120 degree. It is having the sp2 hybridization. Okay, sp2 hybridization means it is a bond angle is 120 degree. Right? Now next that property is the sixth property, that is the shape of the molecule. How is the shape of molecule? Now I explained you that the geometry and shapes will be different. Geometry and shapes will be different if lone pairs are present in the molecule. If lone pairs are not present in the molecule, then geometry and shapes are same. Right? Here, if hybridization is sp2, means the shape is a trigonal planar. Shape is a trigonal planar. In the structure of the reactive intermediate, structure of carbocation, structure of carbanion, structure of free radicals, we are going to discuss in detail the structure, how is the shape of the free radical, how is the shape of the carbocation, and how is the shape of carbocation, carbanion, and etc. Okay, so its shape is a trigonal planar. Trigonal planar shape is here, right? And in case of here sp3 hybridization, trigonal pyramidal shape is there. Trigonal pyramidal shape is there, like trigonal 1, 2, 3, like this. This 1, 2, and one another. This trigonal and pyramid, like this. Pyramidal, trigonal pyramidal shape will be there for the sp3 hybridization. That is the shape of the carbanion is a trigonal pyramidal. And coming to the shape of the free radical, again it is having the same shape, just like carbocation. That is sp2 hybridization. Bond angle is also same 120 degree, and the shape is also just similar to the carbocation. Carbocation and free radical, only difference is that in case of the carbocation there is a carbon bearing positive charge, and in case of the free radical there is a carbon bearing free radical. That is the difference. All properties are generally same, just like similar to the carbocation. All the properties of free radicals are just like similar to the carbocation. Right. Now next property, seventh property, number of unpaired electrons. Number of unpaired electrons. You see here, there is no any unpaired electron. There is no any unpaired electron. That's why the number of unpaired electrons are here 0. Here also there is a negative charge and one lone pair, but there is no any unpaired electron. That's why the number of unpaired electrons are here also 0. Here in this case there is a one unpaired electron. One unpaired electron is here. That's why the number of unpaired electrons are here 1. Number of unpaired electrons are 1. So depending upon the number of unpaired electrons, we can find out the magnetic properties of that molecule. Magnetic behavior of that compound will be found. Okay, so next property is the magnetic behavior. If unpaired electrons are there, then it is called as a paramagnetic behavior. If no unpaired electrons are there, then it is called as a diamagnetic behavior. Diamagnetism and paramagnetism both are the magnetic properties, and these magnetic properties depends upon the number of unpaired electrons. If unpaired electrons are present in the molecule, then the species are called as a paramagnetic species. What? If unpaired electrons are present in the molecule, then that species are called as paramagnetic species. And if unpaired electrons are not present in the molecule, then that species are called as diamagnetic species. Okay. So what is the nature, magnetic nature of the carbocation? There is no unpaired electron, means the nature, magnetic nature of carbocation is diamagnetic. Carbocation is diamagnetic. In the carbanion also, there is no unpaired electron on the carbon, or in the carbanion species there is no unpaired electron. It means that the magnetic property or magnetic behavior of the carbanion is a diamagnetic, right? Alright. So in the free radicals, there is a one unpaired electron. There is a one unpaired electron on the carbon, and that's why the species is a paramagnetic in nature. Magnetic behavior of the free radical is a paramagnetic. Magnetic behavior of the free radical is a paramagnetic. Magnetic behavior of the carbocation is diamagnetic. Magnetic behavior of the carbanion is diamagnetic, but the magnetic behavior of the free radical is what? it is a paramagnetic, right? And the last property, that is the examples here. Here CH3CH2, carbon bearing positive charge is known as carbocation. Here also carbon bearing positive charge is known as carbocation. What is the difference in between these two examples? Here the carbocation is a primary carbocation. The carbon bearing positive charge is linked with only one other carbon atom. Carbon bearing positive charge is linked with only one other carbon atom. That's why it is a primary carbocation, right? It is a primary carbocation. And here the carbon bearing positive charge is linked with two other carbon atoms. Okay, the carbon bearing positive charge is linked with two other carbon atoms, so it is called as a secondary carbocation. If carbon bearing positive charge is linked with three other carbon atoms, then it is said to be a tertiary carbocation, and so on. So here the carbon bearing negative charge is linked with only one carbon atom, that's why it is a primary carbanion. And here in this example, the carbon bearing negative charge is linked with two other carbon atoms, so it is called as a secondary carbanion. What? It is a secondary carbanion. And here same thing is there in all these examples: primary carbocation, secondary carbocation, tertiary carbocation, etc. Same things are there in the second example also, that is the carbanion, primary carbanion, when carbon bearing negative charge is linked with the only one carbon atom, and if carbon bearing negative charge is linked with other two carbon atoms, then it is called as a secondary carbanion. And same are the things in the free radicals also: primary free radical, secondary free radical, etc. In this way we discussed about all the properties of the carbocation, carbanion and free radical at one glance. Okay, I hope you understand it very properly, very clearly, right? So in the next lecture we will see about the structure of carbocations, types of carbocations, structure of carbanion, structure of free radicals and their types we will discuss in the next lecture. So we will stop here. Thank you so much. Thank you.